Hi, this is Hunter's reassessment on work energy. Okay, when we start with work energy, we have to go ahead and define work. And we got a couple of definitions for work. The first one is work is equal to 1/2 mass times velocity squared. We also have two versions of basically the same formula. It's work is equal to force times distance times the cosine of theta, determining its value, whether it's 1, 0, or -1. And they could have a couple of little versions in between. And also, work is equal to force times the change in x. Now, as you see right there on letter D, we have 1/2 mass times times velocity squared is equal to force times change in x. So, for example, if you knew your mass and your velocity, but you wanted to find your force, you could set these two equal. So if you have three knowns, mass, velocity, and change in x, you can find force by setting the two equal. So a very important key to learn. So I also have stated it right here. I got the three choices, and it tells you when you would want to choose those type of formulas. Okay. So right here we got basically the problem calls we got a ice skater. And he's skating and he's got a mass of 69 kilograms. And he falls on the ice, and it's frictionless ice. And he's sliding at a velocity of 11 meters per second. So right here we drew us a little diagram of his body on the ground with mg, and then the force of him sliding towards a wall. Now once he hits a wall, the wall is going to react with the equal and opposite force. So we're going to change that then to the force of normal, and then the downward direction of the mg. Now, so now we got those type of things going on right there. We got a little diagram. We create that. So we choose which formula we're going to use. And basically we're going to use the work formula. Since we know its mass and its velocity, we can use just work is equal to 1/2 mass times velocity squared. And that is equal to change in K. Okay, kinetic energy. So we can say change in kinetic energy is equal to K final minus K initial is equal to work. Then we can go ahead and we know that kinetic final is going to be 0 because the skater comes to a stop when he hits the wall. So that goes to 0. So that leaves us negative K initial, which our initial velocity again was 11 meters per second and our mass was 69 kilograms. So we can go ahead and plug those values in, solve, and then we're going to come out with 4174.5 kilogram meters per second squared, which is going to be a joule. Then we have 4174.5 joules, negative 41.75 joules. So then we can go ahead and do our scientific notation. Now we have negative 4.17 kilojoules. So the work performed by the wall on the skater when he hits it is negative 4.17 kilojoules. Alright, and looking forward to do some more work energy problems with you in the near future. Thank you.